So as promised, this is going to be a quick overview of the math that you need to know to calculate both freezing point depression and boiling point elevation, the two colligative properties that we are interested in. So a couple of things to keep in mind when you are calculating. For both of them, the formula is very similar. It's delta T F for freezing, or delta T B for boiling. And notice that it's a delta T. So what you're calculating is a change in the temperature. So you do need to know the original boiling point or freezing point in degrees Celsius in order to then add the change for boiling point or subtract the change for freezing point. So that's step one. Step two, the rest of the equation is Kf for freezing point, Kb for boiling point. The K is a constant, so that's a given value for whatever liquid you're dealing with. I put the little table from your book, section 3.5, up here. So you can see the boiling points and then the K values as well. So that's just a constant. If you're talking about water, you always use one of these two numbers for your constant. Just choose the right one. The next bit of the equation is the molality of the solution. So this is why we need molality, like only this, but we need it. So molality has to do with the concentration, because the amount of freezing point depression or the amount that the boiling point will be elevated depends on the molality of the solution. And then the final piece that you'll sometimes see in the equation is an I. So your book uses an I, and the I is called the Van't Hoff factor, which you don't need to know. But I equals the number of particles that the solute breaks into. So I'm going to go to the next page and talk a little bit about that. So again, we have our two equations, delta TF equals KF. So the constant times the molality times I, or delta TB equals KB times the molality times I. So I is this little Van't Hoff factor, and this looks at if the particles dissociate. So if we were looking at, I'm going to switch colors, like NaCl is an ionic compound, so it does break into pieces. So it would have a Van't Hoff factor, an I, of 2, because it will break into Na plus and Cl minus. Something like, let's do sodium phosphate, Na3PO4. That is going to break into 4 pieces, because you'll have 3 NAs and 1 PO4. Something like sugar which is a covalent compound, has a Van 't Hoff factor just of 1 because it's just one sugar. So you just have to multiply it by the number of particles because that's the only thing that colligative properties depend on. So change in temp, whether it's freezing or boiling, is equal to the constant times the molality of the solution times whatever your Van 't Hoff factor is, however many particles are in your solute. So change in temp, constant, molality, number of particles. And you just multiply all that together, really, is all you do. And that, the only little bit tricky thing is that gives you the change in temperature. So if you're doing a freezing point depression calculation, you subtract from 0 to get your negative freezing point. If you're doing boiling point, you add it to 100 in order to get the new boiling point, because the boiling point elevates. So today in the lab, hopefully you took the temperature of your salt, ice, water mixture, and you should have gotten a temperature well below 0. Had I had you calculate the molality of that solution, you could have figured out what temperature you should have expected. We could also do the opposite. Since we know the temperature change, we could figure out the molality. Wouldn't that be fun? So anyway, this is just a little bit about colligative properties and freezing point depression, boiling point elevation. I'm going to write out the equations one more time in words so you can remember what all the bits mean. And then you should be all set to finish the worksheet and or do your problem set. So I added just the written out equation. And then just a little reminder, be sure to add the change in temperature to 100 for boiling if you're trying to find the new boiling point, or subtract from 0 to find the new freezing point. So enjoy.